This section is about mains electricity. The important thing to know about mains electricity is that it's different from battery electricity. Battery electricity is direct current, DC, while mains electricity is alternating current, AC. A battery supplies a steady voltage, so the trace on the screen of a cathode ray oscilloscope is a straight line. The voltage of an alternating current supply is changing all the time. The main supply in the UK changes 50 times a second. But why is alternating current used for our main supply?
There's a fundamental difficulty with transmitting direct current, and that is that over long lines the electricity is slowly lost.
The first user has plenty of energy, but as you move further down the line, less and less energy is available to the user.
Where has this electricity gone? It has gone in the form of heat, heating the electrical lines themselves. Therefore, the electricity is not available to the end user on a long line.
So the problem with DC supply is that it loses power over long distances. AC does not. Another advantage of AC is that it can be transformed up to higher voltages or down to lower voltages for different stages of its journey. AC electricity is also easier to generate. From the power station, the grid uses high voltages of up to 400 kilovolts to send electricity over great distances along thick cables that don't introduce much loss of energy. The supply can then be reduced to a safer 240 volts for use in the home. That's still a dangerous amount of energy, and precautions are needed to ensure safety. The 240 volt electricity supply comes into the home through the meter and the fuse box. A fuse box has fuses or circuit breakers to protect each circuit in the house, such as the downstairs lighting, a cooker, or a ring circuit of wall sockets. Each ring circuit has several sockets wired in parallel across the live and neutral wires, so each has the full 240 volt supply. Mains electricity arrives at the plug through the live wire, passes through the appliance, and returns through the neutral wire. Look carefully at how a 3-pin plug is wired up and which wire goes where. The earth wire doesn't carry a current unless something goes wrong. All the wires are insulated to stop any current passing between the wires, and there's another fuse in the plug. Wall sockets are also earthed. If there's a fault in an appliance and the metal body touches a live wire somewhere inside, a person touching it could be killed. The earth wire allows electricity to flow to earth through the earth wire, blowing the fuse and not going through the person.
A fuse is designed to allow several amps to flow before it melts. Its purpose is to prevent fires. It won't prevent electrocution. What does protect you is a residual current device, or RCD. Receiving an electric shock will still hurt, but the risk of electrocution is much less. All circuits have 2 connecting wires. The current flowing in each wire should always be the same. If you accidentally touch a bare wire, the leakage is immediately detected by the RCD, causing a switch to trip.
Describe 4 safety features that can be used in domestic mains electricity supplies. The safety features you should have noted are fuses, which are thin wires that get hot, melt and break the circuit if too much electricity flows through them. Earth wires that conduct electricity straight to earth if there's a fault in the appliance. insulation around the wires and plastic casing around appliances, and RCD circuit breakers, which are more sensitive than fuses and can react immediately to tiny electrical leaks and shut off the supply. There's more about electrical power supply in the physics section of the higher tier science programme. That's the end of the section on mains electricity.